So in this particular topic, we are going to explore two things. One is questions pertaining to odds and conditional probability, and the second part is questions pertaining to different types of selection. So let's first start with questions pertaining to odds, which is very straightforward piece of information. As in, there will be statements given like this, and the statement is odds are 3:2 in favor of India winning the match. And what does that mean is, if we were supposed to figure out what is the probability that India will win the match, that will be 3 by 5, and India will lose the match will be 2 by 5. So what you have to remember here is the wordings, in favor or against, and what ratio it is given. So in favor, and hence 3 by 5 is the probability of India winning. Similarly, the different type that we can explore here is basically odds are 5:7 against of India winning the match. So as usual, first number, which is 5, and because the wordings is against, so that means India will lose the match. The probability is 5 by 12, and India will win the match. The probability is 7 by 12, and this is how you figure that out. So only part that you are going to remember is what the ratio, what the first number is, and whether the wordings are in favor or against of that particular event happening. The next thing is called as conditional probability, or we also call it as Bayes theorem. So huge piece of information. Let's read that out. A factory inspector randomly picks up an article for inspection from one of the two machines, A and B. The probability that he picks it up from machine A is 0.3, and that he picks it up from machine B is 0.7. The probability that machine A produces a defective article is 0.3, and machine B produces a defective article is 0.2. If it is known that he has picked up an article from one of the two machines and it has turned out to be the good article, what is the probability that the machine A that he has picked up the article from? So what exactly is going to happen here is the favorable article, and it has to be from machine A. That is going to be your favorable outcome. So it's a combination of two things. Not only we have to select machine A, but the article should also be a good article. And the sample space will be the article is a good article, so it can be from machine A or either from machine B, but it has to be a good article. So how do we do this? Machine A that he picks it up, probability 0.3. Machine B that he picks it up, probability 0.7. Then machine A can have two scenarios, defective article and good article. I think they have given for defective, which is 0.3, that machine A ka article turns out to be defective 0.3. So obviously machine A ka article turns out to be good is 0.7, 1 minus that. Similarly, machine B, defective article probability 0.2, good article machine B probability 0.8. So the favorable outcome is that it should be a good article and picked up from machine A. So it's a combination of two things, machine A and good article. So machine A ka probability 0.3 into it's a good article 0.7. So 0.3 into 0.7 is your favorable outcome. Because we were supposed to find out the probability, we need to divide by sample space, and sample space is good article, but it can be either from machine A or from machine B. So machine B ka good article 0.7 into 0.8 plus machine A ka good article 0.21 is your sample space, which is 0.77, and probability is favorable outcome upon sample space, that is 0.21 upon 0.77. You reduce that, you get the answer as 3 by 11. So the required answer is 3 by 11. This is called as conditional probability or Bayes theorem also. Very straightforward. Every piece of information will be available to you. All you have to do is read the question properly, find out these facts, try to represent in this particular way, and then you figure out what you are supposed to find out. And the type of questions that we will see is different types of selection. So there are majorly two types of selection. One is a random selection and one is a successive selection. So let's explore what do we mean by random selection. So random selection is all the items are supposed to be selected all at once, something like this. Suppose 3 apples are supposed to be selected from a basket, all three will be selected together simultaneously. But if it is a successive selection, that means we need to pick one object after the another. So that's a major difference between random and successive selection. Random all together, successive one by one. Now this successive selection can be further categorized into two types. One is with replacement and one is without replacement. So what is meant by with replacement? So obviously with replacement is you pick up one article and you keep it back inside, and then you pick up the other article, and then you again keep it back inside, and then you pick up the next article. So that is called as with replacement. You pick it, you pick an article and you keep it back inside, then you pick another article. So what might happen is the articles might be repeated because you are keeping it back again inside. Whereas without replacement, you pick one article and you don't keep it inside, and you pick another article, you keep it aside, then you pick the next article. So there's a major difference between with replacement and without replacement. But what are going to be the implications of that? So with replacement, same object can be selected more than once, that is repetition might happen because you are keeping it back inside. Whereas in without replacement, same object will be selected just once because you are not going to keep it inside, you are going to keep it aside. Then what happens to sample space? With replacement, sample space will remain the same because you are keeping back the articles for the next selection. But without replacement, sample space will keep on reducing by 1. Now, how do we apply all of this to a question? So the question is, from a normal pack of cards, 2 cards are selected. Find the probability that both of them are queens if the selection is a random selection, successive with the replacement, and successive without replacement. So 2 cards, random 2 cards are selected, both are supposed to be queen. So 52 cards, choosing 2 queens out of 4 queens can be done in 4C2 ways, but because we were supposed to figure out the probability, divide by sample space will be choosing 2 cards out of 52 cards, which can be given by 52C2. So your first question ka answer, random selection, both are queens, 4C2 divided by 52C2. Simplification, if it is required based on options, you can do that, or most of the times you'll find the options in this particular format only. Second question, successive with replacement. So 1 queen, first card is queen, 4C1 divided by 52C1 probability, hence divided by sample space, and the second card is also queen. You are going to keep it back inside, and then you are going to remove the second queen. That is again can be happened in 4C1 into upon 52C1, and the first card and the second card both are queens, hence multiplication. So this is your answer for the second question. The third question, successive without replacement. First card is queen, 4C1 upon 52C1, but because it is without replacement, now before the next selection, you are not going to keep that queen back inside. So for the second card supposed to be queen, now you have just 3 queens available. Out of them, you are going to select one, which will be 3C1, and sample space will also reduce because one card has been reduced. So instead of 52 cards, now there are 51 cards only. So divided by sample space becomes 51C1. So this is the difference between successive with replacement and without replacement. So you'll have to be very careful while doing all of this. First card and second card, again, there is a multiplication sign in between. So that's your third answer. Some notes which will help you. If nothing is mentioned about the nature of successive selection, it has to be assumed that it is without replacement. It is always without replacement. With replacement is not the generic scenario. Without replacement is a generic scenario. And the second note, that is that random selection can also be treated as successive without replacement, because what really happens is in successive without replacement, you have to keep a track. You have to keep a track of things that are basically going to be reduced, not going to be reduced, sample space reducing, the cards are reducing, and all of that. So sometimes it might get tricky, and hence to avoid that, what do we do is we go with the random selection because it is easy to understand. All things are supposed to be picked at once. So mathematically, both will give you the same answer, and hence doing random selection in place of successive without replacement is a easy way to look out for. From a normal pack of cards, 3 cards are drawn successively with replacement. What is the probability that the 2 of these are honor cards and one is an ordinary card? So, if you remember the concepts, we had already told you some standard facts about the cards. What are the different types of cards that are available and what are their probabilities basically. But let's do a quick recap of that again. So there are honor cards. Honor cards are basically the 4 cards: ace, jack, king, and queen. So in a suite, there are 4 honor cards. So the probability is 4 by 13 for a honor card. Then there is something called as ordinary card. Ordinary cards are the ones that are without these 4 cards. So obviously they are from 2 to 10. So the probability of ordinary card is 9 by 13. Similarly, then there are face cards. Face cards and honor cards. The only difference is that ace is not the part of the face cards. So face cards are jack, king, and queen. So 3 by 13 is the probability of a face card. Similarly, then there are numbered cards. Numbered cards are from 1 to 10. So the probability of numbered cards will be 10 by 13. So these are the things you have to remember. So now coming back to our question, we were supposed to draw 3 cards successively with replacement. So successively with replacement is one after another, and 2 were supposed to be honor and 1 were supposed to be ordinary. Now the thing is, they have not mentioned the pattern that whether the first 2 cards has to be honor cards or the last 2 cards has to be honor cards and so on. So that gives us 3 possibilities that we can explore. And these are those 3 possibilities. So first possibility, the first 2 are honor, the third one is ordinary. Third possibility, the first one is ordinary and the last 2 are honor. And the second possibility, first and third card is the honor card and the second card is the ordinary card. You know the probabilities, just substitute the values that we had explored. For honor, it is 4 by 13. For ordinary, it is 9 by 13. First card and second card and third card. So they will be multiplied. And the 3 cases, they should be added because either first case or second case or third case. Doing this simplification, you get the answer as 3 times 4 by 13 the whole square into 9 by 13 raised to 1. Answer option 1 for the first question. So remember these additional things as far as the cards are concerned. The second question. 3 archers ABC that are shooting the target. Odds are 3:2 in favor of A hitting the target, 2:1 in favor of B hitting the target, and 3:1 against C hitting the target. What is the probability that all 3 of them will hit the target? So 3 questions are there based on this particular idea. Second question, main data is same, but the question is, what is the probability that the target will be hit? And the fourth one, what is the probability that exactly 2 of them will hit the target? So for this idea, you need to know the concepts of odds in favor and odds against and the meaning of the statements. So the first statement, odds are 3:2 in favor of A hitting the target. So probability that A will hit the target will be 3 by 5 and probability that A will miss will be 2 by 5. Then second statement, odds are 2:1 in favor of B hitting the target. So probability that B will hit the target will be 2 by 3 and B will miss the target is 1 by 3. And the third one, slightly different. Odds are 3:1 against of C hitting the target. So against, so obviously probability that C will hit the target is 1 by 4 and C will miss the target is 3 by 4. Once you do this initial working, it is going to help you tremendously to immediately calculate the answers. So first question, all 3 of them will hit the target. Very clear and straightforward. A hits and B hits and C hits. You know their probabilities and seems to be multiplication. So just multiply all these values. You get the answer as 1 by 10 as the answer for the second question, which is option 3. In the same set, with the same main data, there were another two questions. The second of those questions is this: probability that target will be hit. Now, this is something which is general representation. The target will be hit. So it simply means for you going forward, such types will be that at least one will hit the target. Somebody hits the target. Now, the point is at least one is a complicated cases, because which implies one can hit or more than one can hit. So minimum one should hit. So it can be more than one people who will also hit. And that tells you that, if you remember earlier, we had told you in the probability that whenever you get at least one wala scenario, doing it normally will result in lot of complications in the answers. And to avoid that, you can always go for the complementary events wala approach, which is 1 minus nobody hits the target. So 1 minus nobody hits the target is what you should do. And that is which is easy, because nobody hits the target, meaning all three of them are missing the target. So all three of them are missing the target. That means A misses, B misses, and C misses. You know their probabilities with the initial working. Simply multiply because of and whatever is the answer, which is 9 by 10. Subtract that 1 by 10. Subtract that from 1, and you get the final answer as 9 by 10, which is option 1. So remember this question. The last question from the similar set, very precisely they have mentioned exactly 2 will hit the target. Now again the problem will be which of the exact 2 people will hit the target. So that also will result in 3 different scenarios. Either A and B hits and B misses. Sorry, A and B hits and C misses, or A and C hits and B misses, or for all you know, A misses and B and C will hit. You know all the values, just appropriately substitute. And is multiplication, either first case or second case or third case, so they should be added. One simple calculation point that you can remember for this question is, if you observe very carefully, all the denominators are 5, 3 and 4. So don't try to cancel out anything, because eventually at the end when you are supposed to add them, you'll again have to take the LCM and do the workings again. So to make it easy, what you do is just simply multiply, because all the denominators are same. So the last part of addition will be relatively easy. So just simply multiply and you get the answer as, and then add obviously. So the first answer will be 3 into 2 into 3, which will be 18 by 60. Second answer will be 3 by 60, and third answer will be 4 by 60. So 18 by 60 plus 3 by 60 plus 4 by 60 gives you 25 by 60 as the answer for the fourth one. Reduce by 5, you get 5 by 12, option 2 for the fourth one. So odds in favor, odds against. Fifth one, exactly the same question that we have discussed in the concepts of conditional probability or Bayes theorem, we call it. So we'll not do that here. You can refer the concept video if you want to again. Similar one is there as well, which we will solve. Sixth one, a math teacher gave her a class, 2 tests. 25% of the class passed both the test, and 42% of the class passed the first test. What percentage of those who passed the first test also passed the second test? So very important, the kind of interpretation that we are drawing from here. What percentage of those who passed the first test also pass the second test? So there's a formula for all such types, which you can remember going forward. So probability of B by A is given by probability of A and B upon probability of A. So it would have been probability of A by B. Then the formula would have been probability of A and B upon probability of B. That is the only small change. So A and B and passing in both is given to us. And passing in first test is also given to us, which is 25% and 42%. So 25 divided by 42, after reducing, you get the answer as 59.52, which is first option for the sixth one. Straightforward question with the formula. Seventh one. Now, there is a small correction in this question in your sheets as well, the printed sheets that you would have received. So what I'll do is I'll read the question first here, and then first you make the according changes in the sheets, and then we'll go ahead with the solution, because there's some data which is different than what should have been originally, but some misprinting is there in the sheet part. So just observe that and make the corrections, and then we'll go for the solutions. Amar wanted to be the goalkeeper, but that depends on who is the coach. Coach can be either Suresh or Mahesh. With coach Mahesh, the probability of Amar being the goalkeeper is 0.6. And with coach Suresh, the probability of Amar being the goalkeeper is 0.4. So I think till this part is correct. The next part is where the corrections are happening. Mahesh is coach about 7 out of every 10 games. Mahesh is coach about 7 out of every 10 games. If it is given that Amar is the goalkeeper, then find the probability that Suresh is the coach. So actually there is again a little bit of error in the language. Originally it should have been find the probability that Amar is the goalkeeper provided Suresh is the coach. Find the probability that Amar is the goalkeeper provided Suresh is the coach. So this should have been the original question. Now that we have read it, let's try to look at the solution. And this is what the exact similar question of conditional probability or Bayes theorem, the factory inspector wala question, inspection wala, is this particular thing. So same process. There can be two coaches, Mahesh or Suresh. You know their probability. And when they both are coaches, Amar can be either goalkeeper or Amar cannot be the goalkeeper. So that also we know. Our favorable outcome is that Amar should be the goalkeeper and Suresh is the coach. Combining both of them is the favorable outcome. And sample spaces, Amar is the goalkeeper. Whether coach is Suresh or whether coach is Mahesh, it doesn't matter. So that is the thought process. So let's formulate the data. Mahesh is the coach, 7 out of every 10 games. So 7 by 10, and a 0.7 is the probability. So Suresh will be the coach, probability is 0.3, 1 minus 0.7. Mahesh is the coach, Amar is the goalkeeper. The probability is known to us, which is 0.6. Suresh is the coach, Amar is the goalkeeper. Again, we know that probability, which is 0.4. So our favorable outcome is Amar is the goalkeeper and Suresh is the coach. Whereas the sample space will be Amar is the goalkeeper. So as I said, is a combination of both the things, coach and Amar being the goalkeeper. So Suresh is the coach, the probability is 0.3, and Amar is the goalkeeper at the same time, the probability is 0.4. You multiply both of them, this gives you your favorable outcome. And because we were supposed to find out the probability, we'll have to divide by sample space. Sample space is Amar is the goalkeeper, Suresh can be coach, or Mahesh can be the coach, or is addition. So when Mahesh is the coach and Amar is the goalkeeper, the probability will be 0.7 into 0.6 plus Suresh is the Suresh is the coach and Amar is the goalkeeper is also should be added, because Amar is the goalkeeper is what we are looking, whoever the coach is. Just do the simple calculation, you'll have your answer. So 0.3 into 0.4 is 0.12. 0.7 into 0.6 is 0.42. 0.42 plus 0.12 is 0.54. 0.12 upon 0.54. Reduce the, decimal sign. If you remove, you get 12 by 54. If you divide by 6, you get 2 by 9, 1 by 9, 11.11%, 2 by 9, 22.22%, or 2 by 9 is what you can look at. Option 1 for the seventh one. Conditional probability Bayes theorem. The data might be huge because there will be literally everything given. So that is why it is one of the very easy ideas if you understand that sensibly. Moving on, eighth one. In a race where only two people can participate, probability of A winning the race is 3 by 8 and the dead heat is 7 by 48. What is the probability of B winning the race? So two things that are required here. One, you can do this very easily by using set theory or Venn diagrams because only two parameters are there. So you can make two circles very quickly. Second part is the concepts of races, that is B5, is known to you. because only then you will understand the meaning of dead heat. Dead heat is it's a tie. Both are winners. So let's plot the diagram. One circle A wins, the other one B wins. Intersection, both of them wins. That is the tie, which is the dead heat. We know A wins, that is entire circle of A is 3 by 8. And we know dead heat, that is in between region, is 7 by 48. Both are winners. You know entire circle ka value of A minus this part, you'll get only A wins. So 3 by 8 minus 7 by 8. If you do, you get only A wins this region, which is 11 by 48. If you know this, you can easily find out only B wins. That will be out of 48 parts, only A winning is 11 parts, and both of them winning is 7 parts. That means combining together 11 plus 7, that is 18 parts. So out of 48 values, 18 values are gone. That means you are left with 30 more values. So only B wins. The answer is 30 by 48. But hold on, they were not asking only B wins, they were asking B wins. So B wins yani entire circle of B, which will be 30 by 48 plus 7 by 48, giving you the answer as 37 by 48, option 3 for the eighth. Try to keep things as simple as possible. That is going to make your solutions and the answers very easy rather than the typical complicated approach. And for that, you need to have the clarity of fundamentals. Ninth one, in an archery competition, the probability of hitting the target by Mitul is 1 by 3. So Mitul will miss 2 by 3. By Rahul, 1 by 4. So Rahul will miss 3 by 4. By Bhavin, 3 by 5. So Bhavin will miss 2 by 5. So this is what you need to understand immediately when you read such type of questions. All of them should independently at the same target. Calculate the probability that Bhavin has hit the target, given that two of them have hit the target already. Now, what does that supposed to mean, and what are we exactly calculating? So the favorable outcome is the two people have hit the target, and Bhavin is one of the part of those two people who are hitting the target. That is the favorable outcome. But sample space is Bhavin has hit the target. So first of all, let's try to calculate what can be the combination given that exactly two of them have hit the target. Same working, hitting probability is known to us. Three cases, two of them can hit the target. Exactly two, which two, we don't know. So let's take the cases. First scenario, Mitul and Rahul are hitting, Bhavin is missing. Second scenario, Mitul and Bhavin is hitting, Rahul is missing. And third scenario, Mitul is missing and Rahul and Bhavin is hitting. We know everything. Let's very quickly substitute. Mitul hitting 1 by 3, Rahul hitting 1 by 4, Bhavin missing 2 by 5. Same goes for the other three values as well. And so we should multiply and three cases should be added. This is only the favorable outcome. Let me tell you. Sorry, this is only the sample space that two of them are hitting. Which two? We don't know. Again, the denominators are same 3, 4, 5. So don't cancel out anything. Just simply multiply the numerators and simply add everything at the end. So 2 by 60 plus 9 by 60 plus 6 by 60. That gives you 17 by 60 as the sample space that two of them have hit. But the favorable outcome was that the two people that are hitting the target, out of which Bhavin is one of them. So that means Bhavin should be the part of the two people that are hitting the target. That is your favorable outcome. Means the first scenario where Bhavin is missing the target will not come, and that means the other two will come. Scenario number 2 and 3 is your favorable outcome, where Bhavin is the part of the two people that are hitting the target. Just add those scenarios, that is 9 by 60 plus 6 by 60, which is 15 by 60. So your favorable outcome that Bhavin is the part of the two people that are hitting the target is 15 by 60 and sample space 17 by 60. Probability is favorable outcome upon sample space 15 by 60 upon 17 by 60. 60 60 cancel. Answer is 15 by 17, option 1. Last one. A gun is fired at the cardboard target whose dimensions are 6 by 6. So it's a square basically. If the probability of missing the target is 0.4, find the probability of hitting the target at a point that is at a maximum distance of 3 meter from the center of the cardboard target. So what are we exactly looking again? The cardboard target is of the square shape. Probability of missing is 0.4. So hitting will be 0.6. Then the target is at a maximum distance of 3 meter from the center of the cardboard target. What does that tells you is that the figure will be a circular figure, because circle is the figure that covers the maximum distance. So 3 centimeter is the radius. So that means diameter of the circle will be also 6. That means when we draw a shape which is at a maximum distance of 3 centimeter from the center of the square target, square cardboard target, it will be a circle which is touching the cardboard from all the sides inside. And in this area, we need to hit the target. So obviously, this is the area that we are supposed to hit, which is the area of circle with the radius 3 centimeter upon the total area out of the cardboard area, right? Cardboard area is area of square, which is side square, which is 6 square, into probability of hitting. So area of circle, pi r square, r is 3 square 9 pi, upon area of cardboard, that is area of square, which is side square, which is 6 square, which is 36, into probability of hitting the target, which is 0.6. You do this calculation, you get the answer as none of these, which is 3 pi by 20, which is option 5 for the 10th. So this is how you can solve these types of questions. So with this, we are done with probability 2, that is H5. Thank you so much.